Okay, I thought I'd give you a little bit of help with your homework from chapter 17. So, I'm not going to do all of these, but some of the more difficult ones, as in number 17.7. Draw the line angle formula for each of the following fatty acids. So, let's do palmitate. So, you're going to get a table like this. Actually, this will be the table that you will receive on your quiz for tomorrow. So let's look at palmitic acid. It's 16:0. That means there are 16 carbons, no double bonds. It shows it depicted in this direction from the terminal end to the carboxyl end, but typically we're going to be writing it the other way around, in which we expand the COOH into a carbonate structure. So 16:0. That's 16:0. So it'll be more convenient to write it in this direction. The hydroxyl group, the carboxylate group, and its line angle. So this is going to be carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's the structure of palmitic acid. Now we can draw it in a condensed version, which will be asked for. We write the carboxylate functional group, and we include the methylene units that are going to be repeated. That's going to get a number, and the terminal end CH3. So this is 16, that's 1, that's 2, so this is going to be 14. 14, so the carboxylate, the internal methylenes, of which there are 14, so this guy right there is a methylene, so there are 14 of these, and then the terminal end is CH3, so this is a CH3. Okay, total of 16 carbons, 14, 15, 16. Okay, oleic acid. Here is oleic acid. It's an 18-1, and the double bond starts at carbon, this is 1, 7, 8, carbon 9. And again, we're going to write it the other way around. But this is carbon 9, and this is 10. So that's 7. That's 1 plus 7 is 8. This is carbon 9. So this oleic acid is 18-1. 18-1, and the double bond starts at carbon 9. Okay, so once again we draw our carboxylate. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and that's it. And the double bond goes there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, that's the line angle. Let's draw it the condensed version. So what goes in this box? Let's see, that's going to be 1, 2, 3, 4, 5, 6, 7. So this is 7. Then we do the double bond. And what goes in this box? That's going to be 1, 2, 3, 4, 5, 6, 7. Seven, and the terminal CH3. Let's see if that's right. So 1, 2, 3, 4, 5, 6, 7. And then there's 2, and then there's 1, 2, 3, 4, 5, 6, 7 in the terminal. So there should be a total of 18. 7 and 7 is 14, 15, 16, 17, 18. Okay, so this is the condensed way of drawing oleic acid. 18 carbons, 1 bond. Okay, in this question, we're going to draw the structure of beeswax, which consists of a long chain alcohol called myricil alcohol, which has a total of 30 carbons, and palmitic acid. And we already know that palmitic acid is 16 and no double bonds. So let's start with the alcohol side. So that's going to be CH3, CH2, 29 of these, and we're going to esterify it to palmitic acid. So we draw the alcohol portion, the carboxylate portion, and we're going to put in 16 more carbons, so that's going to be 14, and the terminal end CH3, 14, 15, 16, palmitic acid, all single bonds. So once again, it may be helpful to draw the alcohol portion and the acid portion. Okay, this is a wax. This is beeswax. Okay. Draw the condensed structural formula for a tricyclic glycerol that contains stearic acid and glycerol. What is stearic acid? Stearic acid is an 18O. Lauric acid is 12O, myristic acid is 14O, palmitic acid 16, stearic is 18O. Okay, so we're going to do stearic acid. And it wants the condensed structure. So this is a triacyl, and it's going to start with glycerol. So we begin by writing the glycerol backbone. Okay, these are the oxygens of the glycerol backbone, which are going to be esterified. There's a carboxylate. I can draw that up or down. It doesn't matter. But for purposes of room, I'm going to draw it down. And this is the first carbon of stearic, which is 18O. So we're going to do the condensed. So we're going to draw in these methylenes. And this is going to be 14. Sorry, this is going to be 16. 16. And the terminal methyl group. So this should be a total of 18 carbons. There's 16, 17, 18. 18 carbons. And as you can see, this is an ester function. So we're just going to repeat this 3 times. 16. Methylene, 16. CH3. So this is a triacyl glycerol. Why this word acyl? This group right here is referred to as an acyl group, Okay, so that's the answer here. So now we're going to use caprylic acid, which is 8 carbons. It's saturated. And we're going to draw the line angle formula for glyceryl tricaprylate. And once again, you're going to start with the backbone. Okay, and then we're going to draw the carbonyl. Let's draw it up this time. Doesn't matter. This wants the line angle 8 carbons. So that's carbon number 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. I drew it down this time and I drew it up that time. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, just to remind you, there are hidden here hydrogen atoms. Remember carbon, this is carbon, 4 bonds to carbon. 1, 2, 3, 4. This is 1 hydrogen, so that's 1, 2, 3, 4 bonds. This is like the top. There are 2 hydrogens. 1, 2, 3, 4. Okay, so there's the answer here. Okay, so the next one I'm going to do for you is 31. I'm going to do 31. Okay, we're going to use condensed structural formulas to write the balanced chemical equation for the hydrogenation of glyceryl tripalmiolate, a fat containing 3 palmioleic acid molecules and 1 glycerol. Okay, so let's go to our information sheet and figure out what this is. So it wants the condensed structural version. So here is palmitoleiate, and it is a 16-1, and the double bond starts at carbon 1, 7, 9. So this is carbon 9, and this is carbon 10, which is where the double bond starts. So I'll make that note, 9 and 10. Double bond. Okay. 3 of these things, and we're going to hydrogenate this. So let's start way over here to give us plenty of room. Once again, we have the glycerin or glycerol, same word, backbone with the oxygens. We're going to draw in the carbonyls to complete the carboxyl. So this group here is carboxyl. And we're going to draw this thing. We get a double bond at 9. So this is going to be CH2, 7, because that's 1 and 7 is 8. Now we have this double bond, CH. So this is 9, carbon 10. Okay, so that's, this is a total of 16. So this is 16, 1. So that's 1, 8, 10. I got to do some more. So let me just go back here and double check. The terminal end is going to be, this is going to be 5, 5. Okay. So CH2, 5, CH3. Let's just double check. There should be 16 carbons here. So this is 6, 7, 8, and 7 is 15, and one more is 16. So that's right. So we're just going to draw this 2 more times. The methylene times 7. Double bond, that starts at carbon 9, ends in carbon 10. This is CH2, 5, CH3. Okay, and this is the same thing, CH2, 7, CH, CH2, 5, CH3. Okay, now we are going to hydrogenate this with H2, and let's just use the catalyst nickel. So essentially, we're going to add a hydrogen to this carbon and a hydrogen to that carbon. This becomes a CH2, right? And this becomes a CH2. So let me just say a different hydrogen. Different hydrogen. So this becomes CH2, this becomes CH2, and the double bond goes away. So that makes it easy to write in terms of this condensed structural formula. We're going to start with the glycerol backbone. We're going to put in the carbonyl. So together, this is a carboxylate. We're going to put in methylene groups. And the number here is going to be 14, 14, 14, and this is going to end in CH3. So there should be 16. This is 14, 15, 16, 14, 15, 16, 14, 15, 16. So here's the answer. Okay. Now use the line angle formula to write the balanced chemical equation for the acid hydrolysis of glyceryl trimyristic acid, or myristate. Okay, if you remember, myristate is 14O. So let's just make that notation. This is going to be 14O, 14 carbons, no double bonds. balanced equation. We're going to start with a glyceryl trimeristate. Okay, let's draw that. And this is going to be line angle. So we put in our oxygens, or 3 oxygens. We put in our carbonyls. And it's going to have 14. This is carbon number 1, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to go down again. Remember last time I went up, but I'm going to be consistent. Doesn't really matter, but just be consistent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. Oops, I went up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now we're going to hydrolyze this. We're going to hydrolyze this into products. That is, we're going to add acid. And we're going to break this bond, break this bond, break this bond. We're going to add an H here. So we hydrolyze with water. We're going to add an H there, and we're going to add an OH there. The important word here is balance. We have to write a balanced equation. So we're going to end up with glycerol, OH. Remember, an H adds there 3 times. And we're going to hydrolyze these bonds, which gives us 3 fatty acid. 1 fatty acid comes from here, here, and here. Okay, so that's going to be HO. And this is going to be 14. So that's 1. I'm going to go down, so it's going to look like that. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here's our balanced equation. We got 1 of these, and we have 3 of these. Now, the important thing to remember is this is acid hydrolyzed, so we end up hydroxylating this acid, so it's a full hydroxyl group. In this particular question, we're going to hydrolyze by a term called saponification, the same molecule, only using sodium hydroxide. So this we're going to rewrite down here. O, 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 carbonyl, 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 which completes the carboxylate group. And we're going to have 14. So that's 1. I'm going to try to remember to go down each time. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ooh, it wants the condensed, it wants line angles, so I should do the condensed. Let me do the condensed for you instead of line angle. Condensed. So that's going to be, this is 14O, so there's going to be 12 methylenes. CH2, 12, and a terminal methyl group. CH2, 12 of these terminal methyl, and a CH2 12 terminal methyl. Okay, now we're going to hydrolyze this by saponification with a base, sodium hydroxide. So in this case, we're going to add a hydrogen to the glycerol groups all the way down, and we're going to add a sodium positive ion to what's going to be an oxygen to that. Okay, so again, this is sodium hydroxide and water. Nothing happens to the glycerol. It's going to remain glycerol, OH, 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 OH. So that's going to be the same as what's up here. But we're going to have 3 sodium salts of muriatic acid. So that means we're going to end up with 3 of these. 1, 2, 3 get hydrolyzed. And we're going to have sodium, positive charge, and the oxygen is going to be negative. And we're going to have our carbonyl, and this is going to be the same, CH2 terminal CH3, CH3. Okay, so we're going to take this triacyl myristate and we're going to hydrolyze it with sodium hydroxide, which is saponification. We're going to break these bonds and we're going to get back as a balanced equation. Remember, they're saying balance this equation. We're going to get one of these, one glycerol, so that's glycerol, and we're going to get 3 sodium salts of the carboxylic acid. In this case is myristate. Myristate is the carboxylic acid, and this should be 12. Should have 14, 14, 0, so that's 1, 12, 13, 14. Okay, moving on. This is a very similar question to question number 1731. We're going to draw the condensed structural formula for the product of the hydrogenation of the following triacyl glycerol. Okay, so this is stearate. This carboxylic acid that goes into making this triacyl is stearate. How do I know? That's 16, 17, 18. 16, 17, 18. So basically, we're going to add a hydrogen here because it's hydrogenation. We're going to add in hydrogen to this carbon, add a hydrogen to this carbon, and this double bond is going to go away. So we're going to end up with 3 of these. Let's use nickel. We could use palladium. Let's use nickel. So this wants it drawn as condensed. So I'll draw out these hydrogens. Okay, the carbonyl. And this is stearate. So here's CH2. This is going to be 16 terminal methyl group. Methylenes, 16 of them. Terminal methyl group. Methylenes, 16 of them. Terminal methyl group. So this stays the same, this stays the same, but this gets saturated, ends up with 16. 16 plus 2, so that's 18. So this is a stearate, this is a stearate, and this is a stearate. So it's a triacylglycerol, tristearate glycerol. Okay? Okay, last one I'm going to help you with. Okay, it says draw the condensed structural formula for cephalin that contains a glycerol, 2 palmitic acid, a phosphate, and an ethanolamine that is ionized. Okay, so you're going to have a question very similar to this on your quiz tomorrow. So you start out with a glycerol. So this is a phospholipid that's used to stabilize and make the membrane around a cell. Okay, so here is what this looks like. We're going to start out with glycerol. And once it's drawn, condensed structure, okay. We got carbonyl for these two. So these are fatty acids. These are going to come from fatty acid, but this is a phosphate. Okay, it's a negative charge. And this is going to be palmitic, so that's 16. This guy is a 16O. So this is the methylene is 14. Terminal methyl group, that's 1, 15, 16. Now this thing, this third oxygen of glycerol gets bonded to ethanolamine. Okay, so that's going to be CH2. It's going to be CH2, a CH2, which is ethanol. This part is ethanol, and amine. We haven't learned about amines yet, but this gets 3 hydrogens, what makes it